All right, this is chapter 3-3, function notation. Tonight you're doing 125, 1 through 35 odd of the big ideas. Make sure and put your chapter 3 journal pages in your 3-ring binder and bring it to class, or you can bring the whole thing to class. All right, so the first set of notes is really just some background information. I'll tell you when to take notes. So this is what we call a function machine. In a function machine, you are taking numbers and you're inputting them into the machine, and out comes something else. Okay? We plug something in, something else comes out. Okay? What's happening inside the machine to make it become like the 2 to become a 10? Zach?
It's being multiplied by 5.
It's being multiplied by 5. So my function machine, really, what it's doing is it's multiplying all these numbers. It's like a washing machine by 5, and it comes out, twice as much or 5 times as much. With this, we don't need to really go in order. We can predict if we know the rule. So if I said I don't need to go in order and go from 4 to 7 and list everything, like if I wanted to know the 1,000th number that I put in, if I put in 1,000, I can now predict it because I know the rule. So what would it be if I had it put a 7 in there? 35. Okay, in algebra, we create a table. And we say our input is our x's. And we choose our input. We choose these. So our input, we get to choose, and our output, we use it, all the x's, we plug it into the equation, and what we get out become our y's. Is that making sense? In a word problem, it would look something like this. Logan assembles an outdoor barbecue for $8 each. Write a rule that represents his pay Y in terms of the number of barbecues he assembles X. The first thing you need to do is ask yourself, what is the depender? What depends on what? Jairus? Pay is depending on the barbecues. So, since the pay is depending on the barbecues, the pay is the depender, what do we call that? Nicole?
X.
The depender is the X?
No.
What? Is the pay the dependent or the independent? What is the pay? Ian?
The dependent.
It is the depender. So if it's the depender, what is the fancy word for that? Okay. Caleb?
F of X.
No.
Range.
It's our range. It's our range. So our range is the pay, and our range is like what variable? Yes.
The Y variable.
It's the Y variable. And the independent, Nicole, is the X, which is the domain, which in this case is represented by what? By what? Gabby? Number of barbecues. So my domain is the X, it's my input, and that's the number of barbecues. And my range is the Y, or the output, which is the pay that I get. Now be careful, don't call it a cost, because I will assume you're talking about the cost to make a barbecue. This is definitely about, if I make a lot of barbecues, I make a lot of money. I get paid. If I make only a few, I get paid only a little bit. So what would the equation look like? What would the equation look like? Chris?
Y equals 8X.
Y, the pay, is equal to $8 times the number of barbecues. Now this is a rule that represents a function. They never just ask you to write the equation. They always want you to use it. In Common Core, you also have to use it. So they'll give you a second piece to this. But before we go on to that second part, which one is my input? Which one is my output? I need someone other than this front row and Gabby to answer these questions. Okay, Asia, which one's my input? What variable? X. And which one's my output? Y. Okay, so my input is X, my output is the Y. But they never just give you just this part. They're going to say, can you use it? If he makes 20 barbecues, how much does he get paid? So, John, what am I doing?
You're plugging in 20 for the...
Right, we write the equation again, and then we substitute, and then we evaluate. We write the equation, we substitute, we evaluate, and we get $160. So this is a typical kind of function word problem, only it's going to change a little bit, okay? All right, I'm going to pass this. I'm kind of jumping around all over the place. And now we get into what our lesson is genuinely on in the book, which is function notation. So if I have a rule, a linear equation, function notation is basically a fancy way of writing your S. It's just another way to write the S. The Y, sorry. The Y. Did I say X? So the first thing I want you to look at is, remember, we choose our X's. So I'm going to choose 1. When X is 1, what is my Y? John?
5.
My Y is 5. When X is 2, what is my Y? How about when X is 2, Ariana, what is... It's going to be 7. When X is 3, now this page you're going to write notes. Okay? When X is 3, Jada, it's going to be 9. And when X is 4, McRitchie, it's 11. So, in function notation, we're going to just write it with this fancy Y. And what this means is, the way we read this is the f of x. It doesn't mean f times x. It means the function of x. The f of x. The f of x is equal to 2x plus 3. And what you will also notice is I put my domain in the parentheses. So in this case, notice I'm writing the function of 1. When I use the domain of 1 in this function up here, what does it evaluate to? What is the value for the domain of 1? Yes? 5. So the function of 1 is really equal to 5. Is that making sense? Okay, so how would I read the next one if I put this into function notation? McRitchie?
Function of 2.
What?
Function of 2 is 7.
The function of 2 is 7. So it's saying when my function has a domain of 2, it's going to be 7. And I'm using the f function right up here. What would the next one read? Leora? Perfect. And number 4, Slill? Good. Could I figure out